Hello students, in continuation to our topic integrals, today we are going to take up integrals of the form linear upon quadratic and linear upon under root quadratic. In our previous lesson, we have gone through how to find the integral of 1 upon quadratic and 1 upon under root quadratic forms, right? So, you're familiar with these formula which we used while integrating 1 upon quadratic and 1 upon under root quadratic. So let's have a recapitulation of these formula. 1 upon x square minus a square will be integrated as 1 upon 2a log mod x minus a upon x plus a plus c. Integral 1 upon a square minus x square is 1 upon 2a log mod a plus x upon a minus x plus c. Integral 1 upon x square plus a square is 1 upon a tan inverse x upon a plus c. Integral 1 upon root x square minus a square is log mod x plus root x square minus a square plus c. Integral 1 upon root a square minus x square. Okay, see the difference. Here it is a square minus x square in the denominator, and here it is square root a square minus x square, which is equal to sine inverse x upon a plus c. And integral 1 upon root x square plus a square is log mod x plus root x square plus e square plus c. Okay, so we have previously done that to reduce 1 upon quadratic, we need to make the denominator a perfect square, right? In case of 1 upon quadratic and 1 upon under root quadratic, right? Now, in extension to that, today we are going to take up integrals of the type linear upon your quadratic. Okay, linear upon quadratic, right? See, px plus q is a linear and ax square plus bx plus c is a quadratic, where p, q, a, b, c are constant, right? Either it is of this form or it is of this form, like linear upon under root quadratic. So in both cases, what we need to do is we need to put the linear as a times d dx of your denominator. Okay, a times d dx of denominator, the quadratic one. Okay, in this case also the quadratic without square root. Okay, so you just need to take a times d dx of quadratic plus b. Okay, then we need to open it, right? We have to separate the coefficients of x and the constant terms, and then we need to determine the values of a and b, right, by equating both the coefficients on both sides, right? And this bifurcation will help me to break this numerator in such form that I'll get two integrals. Okay, so we equate from both sides the coefficient of x and the constant terms. A and b are thus obtained, and hence the integral is reduced to one of the known forms. Now see which type of forms we will be obtaining. Okay, so which two forms we will be obtaining? In case of our first form, that is your linear upon quadratic form, we will get integrals which will be of the form f dash x upon fx. Okay, right? F dash x upon fx plus second will be your 1 upon quadratic, right? So whenever we will follow this process, we will definitely find that in linear upon quadratic, it will reduce to f dash x upon fx integral form, right? And the second one is a 1 upon quadratic, ax square plus bx plus c. Okay, so the integral of this is simply log mod fx, and it can be integrated by this expressing this denominator you already know in the form of perfect square and using either of these formula. In case of second type, which is linear upon under root quadratic, we will get integrals of the form f raised to power nx, right, into f dash x dx. And you know the integral of it is your fn plus 1x upon n plus 1, right? And plus the second one will be your 1 upon under root quadratic, right? Which can be similarly by making the perfect square and then using the square root formula. Means definitely in this case, any of these square root formula, number 4, number 5, number 6 is applicable to this solution of second integral, and here number 1, 2, 3 are useful for solving it. Okay, so let us take example each. First question we are going to take up is from your exercise 7.4, and that is question number 18 we are going to take. which is your linear upon quadratic. Okay, and the question is integrate 5x minus 2 upon 1 plus 2x plus 3x square dx. Now, as I already told you that this question will be clearly visible to you that it is of the form linear upon quadratic, right? Linear upon quadratic, right? So either we can arrange it in standard form like 3x square plus 2x plus 1. Okay. Now, as I know it is of the form of linear upon quadratic. So what I need to do, the process we know, I need to put the linear. Linear means 5x minus 2 as a times ddx of denominator. Denominator means my quadratic only, 2x plus 1. Okay, plus b. Okay, you can take in place of ab, you can take as lambda mu also. So a times linear is equal to a times ddx of denominator plus b. Okay, now let's solve it to get the values of a and b. So the derivative of 3x square plus 2x is your 6x plus 2, right? And the derivative of 1 is 0 plus b. Now separate the coefficients and terms of your x, variable x, and the constant term. So I'll get from here 6ax plus 2a plus b, right? So this is your coefficient of x and this is the constant term. And towards this side it is 5x minus 2. So I will equate the coefficients on respective coefficients on both sides. So I'll get 6a as 5, which implies a as your 5 by 6. So I'll get the value of a as 5 by 6 and minus 2 as 2a plus b. So put the value of a here. So it will be your b will be your minus 2 minus 5 by 3. So that is minus 6 minus 5 by 3, that is minus 11 by 3. Okay. Now before substituting it here, I need to check whether the value which I have got means is it making your left and right hand side equal, means have I got the value of a and b and they are correct. So I can check it by putting it in this expression, the expression we just framed here, this one. Okay, so every time it is suggested that for every question you must check it. With a little bit of practice you can do it mentally also, right? So it is 6x plus 2 plus b. Now put the values of a and b, and a is your 5 by 6 times 6x plus 2 plus b is your minus 11 by 3. Just open it. So 5 by 6 into 6x plus 5 by 6 into 2 minus 11 by 3. So that makes it as 5x, and your this is 10 by 6 minus 11 by 3. So 10 by 6 is your 5 by 3. So it is your 5x minus, this is your minus 6. 5 minus 11 is 6 by 3, and that clearly is 5x minus 2. Okay. So you don't need to work out everything in this written form. This calculation can be carried out with a little practice in your mind only, and that you can get that both the sides are giving you the exact values of a and b, means they are the values you got are correct. So what it has given me, I have come to know that 5x minus 2 in the numerator is to be written as a times 6x plus 2 plus b, right? That is your a is 5 by 6 times 6x plus 2 and minus 11 by 3, right? That makes 5x minus 2 itself. Okay, so now let us express my numerator as 5x minus 2 upon 3x square plus 2x plus 1 dx can be written as 5 by 6 times 6x plus 2. Okay, I am replacing 5x minus 2 as what I have got. Okay, 3x square plus 2x plus 1 dx. Now I have to break the numerator in two parts. As I've told you that the first one I can break it as 5 by 6 times 6x plus 2 upon 3x square plus 2x plus 1. Okay, dx minus 11 by 3 times 1 upon 3x square plus 2x plus 1 dx. Now clearly it is visible from here that this integral is definitely of the form f dash x upon fx. Okay, so this integral is of form f dash x upon fx. Why? Because the derivative of 3x square plus 2x plus 1 is 6x plus 2, which is present in the numerator, and definitely I'll get the integral of this term as log mod 3x square plus 2x plus 1. Okay, and the second one is your minus 11 by 3 times 1 upon quadratic, for which I need to work out that reducing to perfect square form, and then I can solve this question. Okay, so let us take, we get the integral as our first term is your 5 by 6 time, and using integral f dash x upon fx, which is log mod x, it will be log mod of 3x square plus 2x plus 1. Okay, and then it is minus 11 by 3 times integral dx upon 3x square plus 2x plus 1. Okay, now we need to change this quadratic to perfect square form. So for it, firstly we need to take 3 common, x square plus 2 by 3x plus 1 by 3. Now adding half of coefficient of x. What is half of coefficient of x? It is 1 by 3. It's square. 1 by 3 square we need to add, and 1 by 3 square, that is 1 by 9, is to be subtracted. So it becomes x plus 1 by 3 whole square. This makes complete square, and by taking LCM I'll get it as, see, like it is 2 by 9. Okay, so it is 3 times x plus 1 by 3 whole square plus 2 by 9, that makes root 2 by 3 whole square. Right, so my this quadrilateral has now changed to perfect square form. So it is 5 by 6 log mod 3x square plus 2x plus 1 minus 11 by 3 times, here this is 1 upon 3 times x plus 1 by 3 whole square plus root 2 by 3 whole square, and this is dx. Okay, so it is 5 by 6 log mod 3x square plus 2x plus 1 minus 11 by, let's take this 3 out, so it is 11 by 9. Okay, dx upon x plus 1 by 3 whole square plus root 2 by 3 whole square. Now see, for the form, it is of the form 1 upon x square plus a square dx. So what was the formula? 1 upon a tan inverse x upon e plus c. Right, so this becomes 5 by 6 times log mod 3x square plus 2x plus 1 minus 11 by 9. Now what is 1 upon e? E here is root 2 by 3. So it is 1 upon root 2 by 3 tan inverse x. X is your complete x plus 1 by 3 upon root 2 by 3 plus c. So it is 5 by 6 times log mod 3x square plus 2x plus 1 minus 11 by 3 root 2. Okay, because this 3 cancels this 9, and it is tan inverse, let's take LCM, and it becomes 3x plus 1 upon root 2 plus c, which is the required answer. So now let us take one question of the form linear upon under root quadratic. For it, I am going to take question number 19 of your NCERT. which is 6x plus 7 upon under root of x minus 5 into x minus 4 dx. Now clearly it is of the form x square minus 9x plus 20. Okay, so it is linear upon quadratic, which is going to change definitely. I told you that linear upon under root quadratic will change to two forms, that is your fx raised to power n into f dash x dx plus 1 upon under root quadratic dx. Okay, so just for this splitting, I need to put this linear as a times ddx of my denominator or the quadratic without this root. Okay, minus 9x plus 20 plus b. So it is 6x plus 7 is a times 2x minus 9 plus b, which is your 2ax minus 9a plus b. Okay, so equating the terms, 2a is 6 implies a is 3 and minus 9a plus b is 7. So minus 9 into 3 plus b is 7 implies b is equal to 7 plus 27, which is 34. Okay, so just for checking purpose whether my splitting is okay or not, I can put a as 3, 2x minus 9 plus 34. Just open it. It is 6x minus 27 plus 34, that is again 6x plus 7. So my splitting is okay. Now express 6x plus 7 upon x square minus 9x plus 20 dx as your 3 times. I am expressing the 6x plus 7 in this form by putting the values of a and b. So it is under root of x square minus 9x plus 20. So definitely it is going to split in the form of break these two terms. Okay, so it is 2x minus 9 upon x square minus 9x plus 20 dx and plus 34 times 1 upon under root quadratic. Okay, so this is clearly of the form like x square minus 9x plus 20 raised to power minus half into f dash x is your 2x minus 9 dx. Okay, plus 34 times your 1 upon x square minus 9x plus 20. Now using that fx raised to power n into f dash x, this integral is equal to fx raised to power n plus 1 upon n plus 1 plus c. So this becomes 3 times x square minus 9x plus 20. Now raised to power minus half plus 1 is your half. So it is 1 by 2 upon 1 by 2, right? Or you may go for say put x square minus 9x plus 20 as t and then 2x minus 9 dx is your dt. So it will be dt upon root t and that t raised to power minus 1 by 2 times dt. In that way also you can do, but it's better that in such lengthy question you use the direct formula. Okay, because it is also important that the time limit is there. Okay, so it is your 1 upon, I need to just make it a perfect square. So half of 9 is 9 by 2. So you need to add 9 by 2 whole square and even subtract 9 by 2 whole square, which is your 81 by 4. Okay, times dx, right? So what is going to happen, that this 2 will go up and it will make 6 times x square minus 9x plus 20. Okay, square root, right? And this is plus 34 times, this is dx upon, it's going to be x as the sign is 9 minus, 9 by 2 whole square, x minus 9 by 2 whole square, and it is, say it is your 24s are 80, 80 minus 81 by 4, that makes your minus 1 by. So that makes minus 1 by 4, okay, which can be written as 1 by 2 whole square. So let's write it in next sheet. So what do we get? We get the first integral as 6 times x square minus 9x plus 20 plus 34 times integral dx upon your x minus 9 by 2 whole square, and 1 by 4 can be written as minus 1 by 2 whole square. Now which formula I'll be using? 1 upon x square minus a square is log mod x plus root x square minus a square plus c. So this formula I'm going to use. So it becomes 6 times root x square minus 9x plus 20 plus 34 times log of x minus 9 by 2, right, plus root x minus 9 by 2 whole square and minus 1 by 2 whole square plus c. Okay, so we may write it as minus 9x plus 20 plus 34 times log of 2x minus 9 by 2 plus, now this originally came from this, okay, so we can write it back like this, x square minus 9x plus 20 plus c, which is the required answer. So in this way we will be able to solve both the forms of linear upon quadratic and linear upon under root quadratic. Both these forms are very important as per the examination point of view. So you can drill as many questions to practice this form. I hope that both the concepts are clear to you. Thank you so much.